Hello and welcome to the webinar on root media and fertility management for organic transplants by John Birnbaum of Michigan State University, co-hosted by eOrganic and North Central SARE. My name is Alice Formiga and I'm the webinar coordinator for eOrganic. eOrganic is the organic agriculture community of practice with extension.org. We are a community of cooperative extension service personnel, researchers, ag professionals, organic certifiers, and practitioners. You can find all our published articles and videos on organic farming on our website at extension.org/organic_production. We're very excited to have John Birnbaum with us online today. John has taught greenhouse management and crop production for over 25 years. During the last 15 years, he has used his experience to develop the year-round MSU Student Organic Farm, as well as organic farming courses, including compost production and use and organic transplant production. Vicki Marone of the Michigan State University CS Mott Group is also online with us today, and she'll be moderating the questions. So now, John, I'm going to hand over the screen controls to you.
Hello. I'm looking forward to sharing information with you today. Thank you, Alice, for the introduction already. So I'm going to not spend too much time here other than to say that we put a lot of emphasis into how to do things on farm and hands-on at the Student Organic Farm, and this is a good opportunity for how we're learning to reach more people through this online experience. The last 13 years or so I've learned a lot about organic farming, and I'm hoping that that combination of that experience and my prior experience with the greenhouse industry will help make this a useful presentation for you. We do a lot of different things at the Student Organic Farm, and mainly I'm referring you to the website there at the bottom if you'd like to learn more about it. But you know, we're doing transplant production pretty much year-round. We start the first week of January, sowing stuff, going into the tunnels in February, and we don't stop transplants until right about the end of September or so. So this is an important part of our production. I wanted to see if we could use one of the pieces of technology here that's available is to get some feedback from you. See exactly how this is going to work or what you're going to see. But we wanted to see if you could characterize yourself in one of these four areas, either that you're not currently growing transplants or that you're growing transplants with non-organic methods, or you grow them with organic methods but you're not certified, or you grow organic transplants but you are certified. And then there's another option there for none of those. This will help me have a little better idea of who I'm speaking with and what your experience is with organic. A big part of growing organically is developing an organic farm plan, and we're not going to address that to the very end of the presentation, but this will help me know whether you've had some experience with organic farming. So what we're seeing is that we can say roughly 50% of you are using organic methods already and either certified or not certified. All right, if we can go on to the presentation. Let's see, what do I have? No, we don't want to do that. And let's
okay,
see.
John, you should be able to click on your screen again and activate the mouse. Hopefully
Okay.
it works.
Webinars.
Okay.
So I am not seeing the...
Okay, just a second. Let's try it one more time. I had to get rid of the poll result. Okay, try it again.
I'm seeing back to the go-to webinar on download complete.
Okay, I'll advance the slide.
It may be that I have to rejoin.
No, probably your window is just closed. Look at the bottom. There's probably a tab on your screen. You can open it up again.
There we go. Got it.
Okay,
Thank you.
Great.
All right. So apologize for that, but our general outline for today is we want to talk briefly about what are some of the transplant growing systems and then we'll talk about root media components and amendments and what are some of the fertility options, and then close with a little bit about irrigation.
Okay, we'll try it one more time. Sorry, everyone. Okay. Yeah, there you go.
There we go. All right, so this topic of organic transplants by itself is quite large. This material that I use, I teach a 12-hour course at Michigan State, and it was originally developed as a 6-hour program for the Moses Organic University back several years ago, and then it became the course at Michigan State, which is now taught online, and that is made up of several different parts. We start out talking about planning and scheduling and different propagation methods, including seed storage, and then we talk about container systems and how do we grow. A big part of the course is the water and root media fertility, which is what we're focusing on today, but we also go into a lot of information about crop protection, as well as understanding how to manage the greenhouse environment to have the proper light and temperature conditions. So we're just going to focus on the lower part of this today. Right. When it comes to the importance of transplants, I'm not going to spend a lot of time here, but this is something that we use when we're teaching vegetables, and there's over 50 different vegetables that we grow at the farm here at Michigan State, and at least 75% of those are started by transplants. So having an effective transplant production method is very important. And some of the most common things would be the onion and things in the Alliaceae, particularly the brassicas and the solanaceous crops. And then if you get into cut flowers and herbs, there's a lot of important crops that we start with transplants. And what that looks like to you, it could be a light bench in your house or a light shelf where you're only starting a few transplants, or it could be a very large greenhouse full of transplants. But we're looking to try to grow a quality plant that has a good balance between the root system and the top growth, and that's going to survive when we go outside. So this is a short list of some of the things that you really look for in a good transplant. Particularly that part of being hardened off and ready to go into the field is important, and it's not that difficult to over-fertilize or grow a plant too quickly, and we don't want to do that. So that's a key part of organic farming, is growing the plant with just the right amount of nutrients. Right. When we look at options for growing plants in any type of production system, there's these 4 main methods, and I'm going to review those quickly here with some slides. So the first would be that you would start seedlings in some type of an open row system, or where they would be each handled individually and transplanted to a cell tray. And if you use this technique, you could potentially have one root media and fertility system for the first stage of germination, and then something that would have perhaps more fertility in the second stage in the flat. Right. You could do something similar using plug trays. A lot of whether or not you use plug trays would be, do you have equipment to sow these automatically, or are you having individuals hand sow each seed into a cell? It does help at some point with speeding up the transplanting as we go to the larger flats. If you are using plug trays, one thing that really helps with root media perspective is to have a deeper cell, and sometimes you have to ask for that when you're ordering the trays. Here's an example of some of the most commonly used trays for transplant production. At Michigan State Student Organic Farm, we would do a lot of things in 128 cells. Things like cucurbits we might do in a larger cell in the 50 cell tray. Another option without using plastic trays is to do soil blocks. This is a method that Elliot Coleman discusses in the New Organic Grower, and there's some other folks showing how to do this. It's not very common yet here in Michigan that I'm aware of. It's something that takes time, but you can use blocking equipment and start with either very small blocks or with larger blocks. You can make your own trays. One of the reasons for doing soil blocks is to prevent this type of root spiraling that can happen in small cells if the plants are in there a long time. These were actually some cabbage plants that I noticed in a field sometime after we had plowed up the field that they still were showing that type of spiraling that had happened. With soil blocks, the roots grow out to the edge and are root pruned by the air at the edge. This is an example of some onion, or green onion transplants that one of our farmers here in Michigan was producing, and then some peppers. It can be useful when you have very expensive seed where you only want to start each one individually and get the best germination that you can, and then they can be shifted up to larger blocks. And this is an example of the type of equipment that you would use. You can make blocks in very large numbers also. There is automated equipment that can be purchased, although as far as I know it comes from Denmark or from Europe. But most of the blocks here in the U.S. are made with these hand production methods. All right, so let's get a quick feel for, see if we can do another question here, whether you are not growing transplants yet, or whether you're using more the open trays and pricking out the transplant flats, or the plug trays with transfer to transplant flats, or if you're doing direct sowing in transplant flats or in soil blocks. Okay, so once we take a look at this, we're going to move on, right? So it looks like we've got a good spread that many of you are sowing directly in the transplant flats with cells. That would be roughly 40%. Only about 10% are doing soil blocks, which is a good number, and then about 30% are either using plug trays or direct transplanting. All right, so let's see if I can get back to the right place here now. All right, so let's move on then. Click on there. Okay. And the one other question that will help me is to know whether you're purchasing a root media that you're growing in, or whether you're making the root media on the farm. As we look at different fertility options, we're going to see that those are the two main things, and that a lot of people who are getting started in organic there are now media that you can actually purchase, but many of the longer-term farmers are making their own root media on the farm, because for a long time there wasn't media that was suitable for on-farm certification. All right, so we're looking at least half are buying in the root media, and about a quarter are making the root media. All right, let's keep moving along here. And the other question is if you are making your own media, are you using compost in the mix or not? So many of you would just answer again that you're purchasing a root media, but if you are using compost, that would help me. At this point I have a fair amount of information about how to make and use compost, but I won't spend as much time on that if you're, well, depending on how much interest there is in compost. And we'll just wait here. Let's see what we got coming up next. All right, so we're seeing that about 10% don't use compost in the media, 30% are buying compost, and 20% are making compost. So it looks like of the people who are, about 50% or so are using compost. Okay. And here we go. Let's start looking then. This way I'm going to present this is it reflects somewhat how I learned how to grow organic transplants. Originally I was coming from the situation of growing with water-soluble fertilizers and peat-based media, and I started asking farmers, well, how do you grow transplants? At that point there wasn't much option about purchasing a certified organic root media, so I didn't learn that way. I learned more how to take simple peat-based media components and make something that was very simple and didn't have the non-allowed fertilizers and wetting agents in it, and then how to use fish emulsion or this omega 666 was the way that I first learned. And then as I read more, I learned how to add organic nutrients to the peat-based media that would help provide more of a base and a longer-term lasting supply of nutrients. So we're going to talk about that as a third option. And then eventually I learned that what the best organic farming transplant growers were doing was that they were using compost. So we spent more time learning how to do that, and that's a big part of what we do right now. So let's look at this idea of what media you can purchase. Again, that's an option that's become more available in the last 5 to 10 years. I think if you asked farmers about what they were using, this Vermont compost would often be considered one of the standards that is out there as a very high quality media. It's manufactured there on the East Coast and used more on the East Coast, but it is also shipped. Some farmers here in Michigan in the Midwest will purchase this. But it's there's a lot of experience with the people that make this, and they give a lot of farmer support, and it's recognized as having a real good nutrient charge that will last a long time. And this material is available through Johnny Selected Seeds as one of the places that will also broker that material. Here in Michigan, someone who's newer to the organic transplant scene is Morgan Compost, and they are working on providing a variety of both compost and a seed starter and a potting soil mix which are suitable for organic certification. So we have more of the organic farmers here in Michigan are starting to look at that as an option. There are also some of the traditional suppliers of potting media that now offer media that are suitable for organic certification. This one by Sunshine, typically, at least the way it has been available, is it doesn't have very many nutrients in it, and you have to start right away with adding nutrients, but it does meet the requirements for organic certification. So there's a couple of suppliers that are doing that. And I think we're going to continue to see more, and it's good to see that many of you are using or purchasing, at least half of you are already purchasing something that is suitable for organic certification. As we move on and think about other options, one of the questions that I wanted to ask for you is whether or not you are using soluble fish products during the organic production or not. That was one of the first ways that I learned about, and clearly it works quite well. These fish emulsion might be something like a 4-1-1 from Fertrell or a 5-1-1, and it's providing primarily nitrogen, but combined with an organic media, it does quite well. So it looks like about 60% or so are using soluble fish products, and 25% are not. So I'm hoping to give you some options to consider that are different than using some of the fish products. Okay. Let's go back here. So if you were to make your own media, what you'd be looking at is buying the components in bulk. This is how we get them in at the Student Organic Farm in 4 cubic foot bags of peat would be the white bags, and vermiculite on the left. And then we're mixing those with 25% vermiculite, 25% peat, and 50% compost that we make on farm. And we just use this simple cement mixer. It could be made in larger piles with a shovel or with a front-end loader, but this method works well for us. One of the things when you look at what is suitable for organic certification is that most all the commonly available potting media components are allowed within organic certification. So peat certainly is. Some people have questions about, is peat a sustainable resource? My understanding is that much of the peat here in North America is harvested in a way that can be sustainable, and the bogs can be returned. That's something that each person would have to consider on their own, but I work on the assumption that peat is a good horticultural material that we can harvest sustainably. Pine bark is another thing that is commonly produced, annually produced, but I would not recommend it for organic transplant production. In conventional greenhouse and nursery production, it works quite well because it's coarse and it doesn't have a whole lot of water holding capacity or nutrient holding capacity, but it provides good aeration. but it also continues to break down and can tie up nitrogen, which is not a problem in conventional production when there's a lot of soluble nitrogen can easily be applied. But in organic production, we're trying to keep nitrogen low, and having pine bark in there can cause problems with there not being enough nitrogen. So I generally do not recommend that, and I've had some experience with operations that have tried to use it and learned that I was probably right, that it did create problems. You may also have access to coconut coir or coir, which is a very good material. It's a higher pH than peat. It has good water holding capacity. It is something, there's millions of coconuts harvested every year, and it will continue to be available. The issue here is the long-term transportation and the cost of transportation to get it to us. Perlite and vermiculite are two materials that are originally mineral sources, and they're heated to high temperature and popped like popcorn, and they are also allowed in organic, but they take a lot of energy to do that. Compost, I think, is going to be one of our best options, and we're going to cover that in a little more detail. So when you're making a media, and if you don't have much nutrients present, and that's what represented here on the left is some work that I did over 25 years ago where we were working with different media companies, and this may be true for some of the organic certified materials that you might purchase, that they may not have many soluble nutrients at all in them, or they may have a nutrient charge. And if you take those and apply liquid fertilizer to them, you won't see that difference, but you need to know what's in the media when you begin. This was some research that we did more like 10 years ago working with organic nutrient sources, and you can see that when we had a media with compost that had nutrients in it on the left, you couldn't see much difference whether there was liquid fertilizer applied or not, whereas on the right you can really see that the liquid fertilizer was necessary. These were organic sources of fertilizer. So what are some of those liquid sources? The fish emulsion we've already talked about. There are questions about how is it harvested. It may be in some cases just residue components from fish processing. It may be something that's actually harvested just to make the fish emulsion. We know we have to be careful about our fish resources that we have available to us. So the other thing is that if you use it, I typically end up smelling like fish emulsion for the rest of the day. So I've been looking for ways how to avoid using that in most cases. The omega-666 is something that's available from California. Harmony Valley handles that, and it goes for almost $200 for a 5-gallon pail, but it works very well, and it can be easily diluted. Other options for mid-crop additions would be to take compost and extract it with water, or to actually brew a tea. We've worked some with that. I know some growers who are using that, and if you have good compost with soluble nutrients, that can work quite well. All of those tend to take time, and do you have the materials available? I'm going to show you some of our recent research and efforts to just take good compost and top dress the plants with compost during production and see that we can get very good results that way. So if you're using one of those soluble materials, you're going to have to figure out how to dilute them. In the interest of time here, I'm not going to go through this, but you have this as a recommendation. Something like the fish emulsion, we would typically have to dilute more than 100 times, depending on how you're applying it. At the Student Organic Farm, I think they're using Fortrel 411 and diluting a 1/4 cup in a gallon, which would be about a 32-fold dilution. That makes a very high concentration, but they're only applying a small amount on an occasional basis. So you have to think about what concentration are you applying, and then how much do you apply. When I first started helping them do the transplants, they weren't getting very good results, and we started talking about, well, how much did you apply, and it was just a very small volume. But when you're applying nutrients, it's a function of both concentration and the volume that you apply, and that's important to remember. So low rates would be something like only 100 parts per million of nitrogen. High rates could be up as high as much as 600 parts per million of nitrogen. All right, and then you can do that simply in a bucket and apply it with a watering can or a tank and apply it with a submersible pump through your hose, or you can make up a concentrated solution and apply it through an injector. My observation with most farms is that they're just making up the diluted material and applying it with a watering can or a pump. Making the compost teas can be very simple, also done in a bucket, or some of the larger facilities are using very large brewing equipment. Your next option is to consider adding nutrients into the mix before you start planting. And if we start with something like peat, for example, we would typically want to add some lime into it, which would increase the pH as well as provide calcium and magnesium. But there's a wide range of things you can apply. It's important to get to know your media and how well Transplant do. This example shows you these are all the same age. Just the plant on the right, that media had 50% compost, which can make a pretty dramatic difference. If we look at the range of things that are allowed with organic certification, there's quite a few things, as long as they're from primarily mined sources. So something like potassium sulfate, you'd have to be careful. It can come from a manufacturer source, which would not be allowed, but from a mine source, it is allowed. And there are great information available about how to use these. Typically, it's going to be in, say, 1 to 2 pounds per cubic yard of media. You can also use some plant-based media, such as alfalfa meal is probably one of the most common, and I'm going to show you some experiments that we did with that. And then there's also animal-based amendments, such as blood meal and bone meal, that have been used for a long time as a source of organic nutrients. If you're looking at how to apply these, it's important, again, to have a rate, and the most common rate that I'm familiar with is to work with how many pounds per cubic yard. One of the publications available at the ATRA website shows, or used to show, 40 or 50 different potting media or transplant media. And if you take the time to work through and recalculate all the recommendations into one common unit, 30 of those were almost all exactly the same mix, just given in different ways of measuring things. So the idea of a pound per cubic yard, a cubic yard is 27 cubic feet, is a good way to begin. One of the most common recommendations that a lot of farmers who make their own media would be this one by Elliot Coleman, which is mentioned in the New Organic Grower, of taking equal parts of blood meal, bone meal, and rock phosphate, equal parts by volume, and then adding that to the potting mix at a rate of roughly 14 pounds per cubic yard. And it ends up making a fertilizer material that's about equal amounts of N, P, and K. Another material that we started working with, because early on I think there was some concern about people getting into organic transplant production and where would I get a material that was safe, and some people wanted a plant-based material. This was something that we started working with over 10 years ago when it first came out, the Bradfield material, because it was OMRI listed. It's a mix of primarily alfalfa supplemented with potassium sulfate and some poultry protein, humates, and molasses. Alfalfa is something that you can get in a variety of forms, from baled hay on down to rabbit food, and it can make a good fertilizer, but it needs time to break down. That was one of the first things we learned back 15 years ago when I started working with organic fertilizers, that when you put them into the mix, there can be some very rapid breakdown, lots of bacteria and fungal growth, and that you can't seed into that or sow into that right away. You need to allow at least 2 to 4 weeks for that to process, and then in this case we replanted in that same media and it worked just fine. So you have to have time for these organic materials to develop. This was an experiment that Ajay Nair did when he was a graduate student here at Michigan State, and working with the Bradfield, it was called Tasty Tomato 333, and he added it at 4 different rates, either 10, 20, 30, or 40 pounds per cubic yard, and then incubated the material over a period of time and sowed at several intervals. So this was what happened if he sowed the same day that he mixed it. We see that we did not get very good germination at all. So that we would not recommend. If we look at 1 week after planting, we got pretty good seed germination, with all the rates. The highest rate, there's maybe some inhibition there. And these tomatoes were just sown directly into these trays. And if we look at 2 weeks after planting, things were still okay, looked good. But at 3 weeks, the material actually started to break down enough that some of the nutrients were beginning to accumulate. And at 4 weeks after transplanting, you can see in the lower right corner there that the germination began to be inhibited. So we would say, based on this, that with any of the organic amendments, you need to allow them to have time to break down and test to make sure that they're going to work all right. Okay, the fourth option here is putting compost in the media, and based on my experience, that's been the one that has worked the best. You need to be, some cases you can purchase compost, some cases you can make the compost on farm. We actually started out with that goal of making compost for transplants and for compost tea. Some people just put whatever they happen to have on the farm into the compost pile, and that's one way, and you could use that material for increasing fertility in the field. But this is a recipe, this idea of taking straw and hay and peat and shavings, something that's available pretty much anywhere in the United States, and making a mix. And I just want to go through and show you some examples of how we've done this. In the beginning, we started taking these materials and layering them in a manure spreader. We included an equal part, or 1/7 part soil, also in the mix to help with inoculating with beneficial organisms and to provide cation exchange capacity. We would take that and run it through the spreader and then let it sit for 2 to 4 weeks as it heated, and once it cooled, we would pick it up again with the front end loader and put it in the spreader and then repile it. And in a relatively short period of time, in about 2 months, the hot composting phase would be completed. We would wait for it to mature, because that's a key point of what using compost is, that it needs to be quite mature, and then it worked very well for transplants. What I don't show in this recipe and some of the following ones is the use of leaves, and those leaves are probably one of the best things that you can get available on the farm, and that worked very well. Just some other examples of how we make compost pile using a pallet system. This is using those same types of recipes. We typically will turn it, but the pile on the right ended up being used where it was not turned, and after quite a few months it made very good broken down media as long as it was kept watered. More recently, we've been doing this as part of the Organic Farmer Training Program. All the students get a chance to make the mix, and this would be a batch for one pile. It would be 3 bales of each, and you can see it would total roughly $66, not counting my time and the effort to go and get these, but just for the materials. And we would take the materials and we make 3 piles like this for the farm, and everyone gets a chance. Basically each bale becomes a layer, so we end up with 15 layers. Lots of water has to be added to make this work, but we end up with some nice piles, which this could be done with a front end loader. We do it all by hand so the students can see how that's done. Simple mixing after the material is heated initially, and they typically heat to 140 to 150 degrees Fahrenheit. Adding a lot more water is an important step, and then over time, as you would expect, the piles shrink. And down to the end in the fall, this is in October, we collect up the material, and you can see that one of those piles ends up making about 1.5 cubic yards. And if you look at buying 1.5 cubic yards of compost, that $66 of input materials is not that high for something that's going to be very reproducible and very successful for growing transplants. We would then take that in and store it in the greenhouse so that it could continue to mature, and we're able to use it in January. I think if it's not going to be warm, it may take as much as 12 to 18 months before it would be ready for transplant production. So this was a batch that we just did for some research just a few weeks ago, putting 1 bale of each, and you see it basically fills a pallet system of just a box with pallets. and that those piles heated up to 160 degrees. It says 3 hours there, which is not true. That should say 3 days. I'm sorry about that, but they heated up very quickly. And the heating is important for organic certification, that you would get at least 130 degrees and that you would turn the piles enough times so that the whole pile got to that temperature. Working with compost, a key part of it is to know that the material has to be mature. And so that even though it looks finished after a few months, you can't grow plants in that quite yet. It may take another 4 months before it's ready. Here's an example when we were first starting to learn how to grow organically. I was still doing flowers and poinsettias, which I knew a lot about at the time, and you could see the plant on the left was this nitrogen starved. If we just added nitrogen, it worked. The plants grew fine, and what we learned is that we just had to wait longer and let the compost get mature. And we understand why, and this is important for all organic fertilization, whether it's in the field or in the greenhouse. And I didn't say that in the beginning, but sometimes learning about organic farming through or growing organic transplants is a little simple way of doing it before you get out into the field. But we're depending on the biological organisms, the soil food web, to break down the organic matter into available nutrients. And initially that step drives the pH up. It can be as much as 8 or more. And later, over time, as the bacteria further degrade the material, the pH can come down to about 7. And that would tell us that the material is ready. And just one other example with impatiens is that we learned, again, the most limiting factor was the lack of nitrogen. And there's a reason for that. And this is how I generally share that if you look at nutrient ratios as they are on a fertilizer bag, you would look like the graph on the left, and how we apply nutrients on a percentage basis, that it looks like we apply equal amounts of nitrogen and potassium. But if you think about how nutrients are applied based on what you learned in chemistry about atoms or moles, and you realize the fact that an atom molecule is quite light, there's a lot of them, and there's actually a lot more nitrogen than any other nutrient that we're applying. And what organic transplant production often comes down to is managing the nitrogen in the system. And we need enough, but not too much. All right, so just a few things to wrap up on this compost section. One of the things we did last year was to take 23 different composts that we had made here at Michigan State over a 2-year period. The ones that are in the boxes, so 1 through 5 and 14 through 18, are ones that had a recipe similar to the ones that I just showed you previously. And this will give you some idea about looking at this data either now or when you review the material. There's a handout that you can print out of what's typical levels. So here we were getting about 20 to 1 carbon to nitrogen ratio and about 1 to 1.5% nitrogen in those composts. They have a low level of phosphorus, but that can be increased by adding something like rock phosphate or manure or something to the composting process. If you look at number 6 and 21, the reason probably why they're so high, those composts is that they are manure-based composts. So a little bit of manure will bring in some phosphorus, and phosphorus is an important part for getting transplants off and getting a good balance between root and shoot growth. And potassium, you can see we're running about 0.5 to 1%. So I'm hoping that this data might be valuable as if you have a compost and you get a test of it done, that you could see how it compares to the one that we're using. But the ones that we're using that are mature are in the pH range of 6 to 7. pH is something that's really important. You can see many of the manure-based ones, number 6 and 21, and 22 and 23 were horse manure composts that I had made at home, have a higher pH and are going to take more time for that pH to come down. The saturated media extract tells us about the soluble salts that are present, and you can see again that the manure-based ones are quite high, and so there you would use only a small amount of those composts compared to the transplant ones. Those typically work well if used at either 25, 50, or 75%. And that's one of the things that you would have to determine is how much to use. Nitrate is a good indicator of whether the compost is mature, and here you can see that we are getting levels up to 200 to 400 parts per million. But when we dilute that out in a mix with 50% peat and vermiculite, those levels come down to very acceptable levels. What we would not want is something that has these high levels of ammonia in that some of the manure samples have. They definitely need to age more. So even though many of you are purchasing pre-made media, I would hope that this information about how to use, potentially in the future, make your own and to use compost is useful to you. It's also important, even if you're working with a manufacturer of media, that they know about compost and you have a way to evaluate their mix or media and if it's right for you. Now, this phosphorus availability is important. I like the idea of having some soil in the transplant mix, not very much, but as you know, soil can bring along potentially disease organisms or weed seeds. I always laugh when I read the books about putting soil in your oven in your house, because anybody who's ever done that knows that that's totally impractical and not a good idea. But putting soil into a compost pile gets you to the 150 to 160 degrees that will remove most of the weed seeds and any potential pathogenic organisms, and is a great way to clean up soil and have it in your transplant mix. All right, here's an example of the plants on the left where we added compost and again providing just enough nitrogen and a balance of nutrients to be successful with the transplants. If you're making your own mix, you have to decide how much compost to put in, and a simple way of doing that is a test where you can put in different amounts. I usually recommend 25, 50, and 75%, or you can have a test done, and I've provided some recommendations here for how much you would use based on what that test results turn out. We've mostly talked about hot compost or thermophilic compost. We've been working the last 2 years with worm castings, and we're doing worm composting of food waste. And the worm castings clearly are a great opportunity for providing nutrients in a transplant mix. Usually they'd be used at a lower rate, right? And they can be very successful. The nutrients become soluble, particularly phosphorus. Although I like to try things that I wouldn't expect to work and see what happens. We recently germinated some in 100% worm compost, not worm castings, but worm compost, and we got pretty decent germination. So we're going to continue to work on that. But I think taking that worm composted and applying it, and this is some example from some work last spring where the nutrient deficient transplants, were again just the nutrients in the media had run out, and what we did was top dress the plants with worm compost, and an example would be not very much, as little as a cup per flat. We were testing rates of half a cup per flat or 1 cup or 2 cups per flat, and somewhere in that 1 to 2 cups per flat would make a very dramatic difference in the transplants. And it didn't take that much more time to sprinkle it over the top of the flats than it did to mix up fish emulsion or mix up some liquid fertilizer and apply it. So this is a system that could work out well for producing things on your farm. This is one of the last questions that we'll do here, just a quick check-in to see if any of you are currently using dried compost as a way to improve the fertility of your transplants during production. I hope this is something that you might take away today as an alternative to fish emulsion, and that can be done fairly quickly. It helps if the compost is dry, and what we normally do are putting it in a colander or something, a sieve, that we then just go over the top and sprinkle it on the plants. So some of you are, and at least 23% or so are use it this way, and we'll see during the questions if you have questions about or comments about how that's working. But I think that's going to be a big help for organic transplant growers. All right, and wrapping up here, we need to keep in mind that pH is important. I spent the first 15 years of my academic career really teaching farmers how to manage pH by adjusting their water-soluble fertilizers and using acids, primarily because peat-based media without any soil in it can change very quickly, particularly in small cells. What I've learned is by adding 50% or more compost to the media that pretty much all those problems go away. In our case here in Michigan, our water has a lot of dissolved alkalinity, bicarbonate alkalinity. So we call it affectionately MSU liquid rock. It's like every time you water, you're applying lime to your plants. And so you have to account for that. And much of the Midwest is that way. That would be quite different than on the East Coast where you have granite aquifers, and there they might actually have problems with the pH falling. But learning how to manage pH is could be a webinar in itself, but one of the easiest ways to avoid pH problems is to have a root media that has compost or a small amount, 10% or more soil in it, and that provides enough buffering capacity so the pH doesn't change rapidly and the nutrients stay available. The other thing that can influence your pH as well as your nutrients is keeping track of your watering. And with organic farming, we need to be very careful about how much water we apply. We learn in the teaching program that one of the things that can introduce a lot of variability is if a student goes in and tends to water things very thoroughly, and you can leach all the nutrients out. And generally we don't want that to happen. We want to keep the nutrients in the media. If for some reason you have too much nutrients, that leaching would be a good strategy. But we're generally looking to just water so you get a small amount of dripping and you know that water has reached the bottom of the containers. And so, key point, be careful with watering when you're growing organic transplants, that you want to keep the nutrients in the flat and not be leaching them out. Whereas many greenhouse growers using water-soluble fertilizers, that's not that big an issue because they're constantly applying fertilizer. In some cases, they have to be leaching in order to get rid of excess fertilizers. Right. The other thing thinking about watering is that we didn't get to talk about the stages of transplant production, but stage 1 is just when germination is first occurring. Stage 3 is when most of the growth occurs, and stage 4 would be like a hardening off stage. And we want to think about in those early stages keeping the media very moist till its roots develop, and then gradually over time allowing the flats to dry out more and more to the point that in stage 3 and 4 we would actually see some wilting in order to help toughen up the plant. So we've covered a lot of information here today. We still have close to half an hour for questions, and I'm looking forward to answering your questions. The one last topic that I wanted to share briefly is that if you are going to grow certified organic transplants, you would need to know how to fill out the farm plan, and that's something that you can learn about more by contacting one of the many organic certifiers in the country. They can provide farm plans and help you see what information. These farm plans, simple ones, are also available at the ATTRA website, attra.org, and you would have to fill out forms that talk about where did you get your seeds, are they organic, making sure they're not treated. If you purchase organic seedlings, you know, who grew them and how are they certified and who certified them. You would also, if you were doing them yourself, you'd have to have a list of all the materials that you added and where they came from, and make sure you are only using approved materials, not restricted or prohibited materials unless you talked about those with your certifier. So it takes time to keep track of what you put in, but that's just one part of a successful organic transplant production. And with that, we've covered, again, a lot of these topics. I'll just close. We're going to take questions now. I think we'll just, well, we could do this one last question here, and this will be the end, and we'll move to your questions. Again, we went through this quickly. There's lots of places to fill in the blanks, but we do have a 5-week course, which is primarily just taught for MSU students at this point, but I'm looking on bringing that and making that available for organic farmers, and I'm interested in how many people would be interested in such a course. But hopefully now you've been working on your questions, and we'll switch over and C, right? So that there are about a third or so of that would be interested. So I've given you my contact information there, so that if you would like to be included on any announcements when we do offer those courses, you can contact me. But looks like, Alice, I think we did pretty good. It's a little about 5 minutes over, but let's go ahead and switch to questions.
Okay, we're about to start our question and answer period, and for anybody who missed the very beginning of the presentation, you can use the question box on your screen to just type in questions and hit return. If you don't see that question box, you can just click the small plus sign next to the word question to open it up. And in a moment, I'll be turning things over to Vicki Marone of Michigan, who will be reading the questions out loud, and we'll answer as many as we have time for. The webinar is being recorded, and it will be posted to the link that will shortly appear on your screen as a PDF file. And the slides will be there as well. And if after the webinar you have additional questions, you're welcome to use the online Ask an Expert service with eExtension at extension.org/ask. Finally, we really value your feedback, so we'd very much appreciate it if you could fill out our follow-up survey, which you'll be receiving in an email today following the webinar. So, Vicki, I can pass things over to you, and we can move on to our first question.
Okay, thank you. So one question that several people asked about was a concern for the potential of weed problems in their hay when they're making compost.
So that's a good question, and one of the main things that I do is keep track of where the hay is coming from that I use in the compost. All of ours comes from a neighbor of mine who, and I know the fields, and I know that the weed seed pressure is minimal, but we're also taking good care during the composting process to make sure that we're getting the temperatures up over the 130-degree mark, and that we're turning the piles so that they all reach that temperature as is required by for organic certification. So I won't say that we don't have any weed seeds, but we have minimal weed seeds present. I would think that certain hay sources could lead to a lot more weed problems, so that's the main advice I would give, is to use a reliable hay source, something that where you know about where it came from, and that it would have minimal weed seed. Otherwise, you're going to make sure that your compost process is doing well.
Thank you, John. So one question also about ingredients regarding making compost is the wondering if there's a bacterial contamination when you're using blood or bone meals.
So one of the reasons why we made we worked with the recipe that we did from the beginning was to avoid that potential concern that some people have. From what I've read, I am not particularly concerned about the blood meal and the bone meal that are currently available. I know that we're seeing increasing evidence that there may be some pathogens in those that, well, the concern seems to be with pathogens that could be potentially transmitted to humans, and I'm not aware currently of that being a major concern or something that we need to focus on. The hot composting process, again, would minimize any of that, but I think I'm not aware of problems with that. I think that the way we address that, both for the transplants, and this issue comes up also with compost tea, is to just not use those materials. And that was one of the reasons why we also looked at the alfalfa meal as an alternative to blood meal and bone meal. So there are alternatives if you're concerned about that, but to date I have not seen any evidence that there is a problem with using blood meal or bone meal.
Okay, so there's a lot of concern about the ingredients with compost, regarding even the price. One person asked about the approximate cost for 1.5 cubic yards of compost, and so they can make an estimated budget.
So here in Michigan, when I think about purchasing compost that I would be confident of, we have one of the major suppliers is selling compost in the $30 to $40 per cubic yard, plus delivery. And delivery might be as much as $5 per loaded mile. And that's where I think that making it, showing the recipe that I did, that the component costs are within a reasonable level. You know, you have to add in the labor costs, which would certainly increase the cost of making it on farm. But when you go to buy it, again, I think that $25 to $35 a cubic yard would be a starting point. But you're not wanting to go down to the municipal place where they give away compost for free, or where you could get it for $10 a yard and get that for growing your transplants, because you don't know what's going to be in that, and it's certainly not going to be certifiable. For the example, that's a good point that I didn't make, is that if you're going to purchase compost and use it in a system plan where you're seeking organic certification, you're going to need to be able to get records from whoever made the compost that shows that it indeed was heated, the appropriate temperatures and the appropriate number of times and with mixing, and what the ingredients went into it. The composter that I'm thinking of will provide that information to anyone who buys his transplant mix and is looking at and doing organic certification. Let's see if I answered the question well. Again, it was back to the cost of those materials. I think that other than the concerns that I already raised about getting good compost, would be looking at the delivery cost of that, of the transportation cost of the compost. One of my perceptions is that a key to growing organic production, we've done a lot of work over the years on cover crops and how to use that to improve soil fertility, but there's still a lot of opportunity for compost. I will take this opportunity to add about the worm compost. Something that I didn't mention is that the thing about the worms is, if you learn how to use them and provide an acceptable environment, they will do a lot of the churning for you and a lot of the breaking down. I think that over time we'll be able to have more small-scale producers have a worm compost area. One of the things that we were researching last year was to demonstrate that a hoop house and that with an internal blanket will provide conditions that allow worms to survive over the winter. And we had a bed that was roughly 10 feet by, let's say, 5 feet, and covered with an interior plastic layer in an unheated hoop house, and we're able to maintain 50 degrees in that bed throughout the whole winter. Part of that depends on how you're feeding the worms, and you don't want to overdo it because you can cook them with too hot a composting temperature. But I think more and more farmers will be able to maintain a small worm composting operation to get some of these locally available nutrients and not have to buy them in. Right now, worm compost or worm castings can be a little more cost prohibitive. They're higher than regular compost, but from what I can see, it would be a good investment as a nutrient source that can be made locally, as opposed to bringing in mined minerals that often come with a high transportation cost. Quick example would be phosphorus. You know, I just saw an article that someone sent this week about how people are beginning to realize that the amount of phosphorus available for farming in the future is limited, and that we need to start thinking about those sources. And composting and worm composting is one way to get locally available sources, including manure, into a form that's available and good for farming and transplant production.
Okay, thanks, John. This leads us right into this next question regarding if there are any concerns about pathogens in the worm compost, since the person mentioned that it doesn't heat up like it does in a conventional compost.
Okay, so concerning pathogens, particularly in the case but we're working with food waste from the campus, that's something that I'm still learning more about. Our initial work to be sure that we do meet organic certification is that we're pre-composting with a hot composting phase. And that provides certain advantages for managing odors and flies, which can be present in food waste. And then it also addresses this issue of any potential contaminants. I have not sat down and talked with our certifier for the student organic farm yet to ensure that what we're making will be suitable for use on the farm. At this point, we haven't started using any of the worm compost on the farm. One of the reasons is because of that. There is some information available from the National Organic Standards Board Task Force on Compost and Vermicomposting that gives some recommendation for vermicompost. I'm sorry I didn't review those before today to remind myself of exactly where they're at, but a lot of what we're doing is completing the worm composting, and then there's also an extended period of time where that's aging as a way to try to minimize any potential risk for contamination. We will see that because we're doing the food waste composting, that things like tomatoes and cucumbers or cucurbits and pepper seed can come through the worm composting process, and that's something that we need to learn more about. But a number of the commercially available worm casting materials that I've looked at online and that are available, some of those organizations are using very managed inputs, not food waste, but other inputs to be sure that they have a clean product that they're offering for people for growing plants. So it's, in each case, it's going to be a matter of checking with your source and checking with your certifier. I'm sorry I can't be more accurate or exact at this point, but it is something that we will continue to work on and learn more about to be able to advise farmers who are doing on-farm worm composting of exactly what records do they need and what methods do they need to use to make sure that the material is safe and will meet organic certification standards.
Okay, John, thank you. So, okay, John, thank you. So we have another question about recommended for organic sources. You did mention Johnny's for some of the products. Do you have other recommendations for sources that people can purchase?
Off the top of my head, I don't have, well, for nutrients, one of the places that I mentioned, and I'm trying to think about what we use, what websites I have. In the course, I just refer people to a number of different websites. Fertrel.com will get you, they provide a number of fertilizers that are suitable for organic certified systems.
Peaceful Valley.
Peaceful Valley out of California also provides a fairly substantial list of both soluble and dry fertilizer or fertility materials suitable for organic systems. And then I think it's working with other local organic farmers, asking them what they're using, where they're getting their materials, because minimizing transportation cost is an important part of making these methods economical. I don't feel like that's a great answer to give you sources and supplies, but that's something that, again, it's from the university, it's a little more difficult. I'm trying to not necessarily recommend specific companies other than to give examples of where you can find these materials. There's a good answer. At ATRA, at the materials that they have available, there's one on making organic potting media that has an extensive list of suppliers of both organic potting media and sources of material to put in the potting media. They also have a very good bulletin on producing organic transplants.
Okay. So when you when you use phosphate, somebody asks, does it have to be ground powder form, or does it just granular form work okay?
The experience that I have is with the more finely ground powdered rock phosphate that we bought in 50-pound bags, and I know that that works in a timely way, particularly if it's put into the composting system. I have less or no experience with the coarsely ground materials, so I can't say how well they would work, but what we would expect logically is that the coarser the grind, the slower the solubility, the longer the release time. Although it would be nice to have more information about what happens when we put some of these minerals into a compost pile where we have very high biological activity, and we would expect them to be coming available more quickly. I can't say for sure about the coarser grind materials for phosphate.
Thank you, John. So we have a question here that's, I think, important for us to consider. This person asked specifically about endomycorrhizal inoculants as seed bath or soil addition. But maybe you could also comment on the other type of inoculants that are offered for sale to add to your compost.
Okay, so not starting first with what's for sale, but first starting with the idea of having good biology in the transplant media. I think that that's a very important point and something that you can get from making your own materials. Making good compost on farm and applying some of the local soil is going to be one way of having that biology there. We tend to, again, make something that the finished C to N is more in the 15 to 20, or let's say 20 to 1, and I think that's going to help in terms of having a good range of biology present. There is some evidence that came from some researchers at Cornell where they grew transplants in different media and then planted those transplants in the field and looked at how the microorganisms that were in the rhizosphere in the root area of the transplants continued to spread as the roots grew through the soil over the growing period. And they found that it did make a difference, and that the organisms that were present in the transplant did impact what was happening to that plant as it grew through the year. So I think that's really good evidence that we should be thinking about what's there. More specifically now to what you can buy, there is one of the potting media companies provides a mix that is inoculated with mycorrhiza. I tested back long before I was doing organic research. I tested some of that material when it was first coming out with bedding plants, and we grew bedding plants in the flats and then planted them out in the field, and we did not see any visible differences, but we didn't have the ability at that time to do the tests of were the plants inoculated with mycorrhiza and what other beneficial effects there might be. We certainly know that mycorrhiza are going to benefit some species or some types of plants more than others. It's certainly an option. I think that making compost and growing transplants is a way that we're going to be able to take advantage of beneficial microorganisms in the future. I've had one student work on something that is called bokashi. It's a type of compost where you're selecting certain organisms, or you could be using something called that's commercially available called effective microorganisms, or EM, which in some sense is a bugs in the bottle kind of approach, but it has a wide variety of materials in it and can be added to compost. Or in the case of bokashi, you may actually be doing an anaerobic step, but trying to get beneficial organisms in that then would continue later when you use that material. many farmers around the world, there's methods where you can actually go out into healthy areas or wooded areas near your farm and put something on the ground that might encourage bacterial or microbial growth, particularly fungal growth. Examples would be putting out cooked rice or putting out straw or other organic materials. They can become inoculated by the local fauna in the forest, and then you can collect that up and bring that and add it to your compost pile, or add it into compost tea. And I think in the future we'll see more information about how to use these beneficial organisms, both from that we can collect. The other example that I'm just learning about now is with the worm compost. Apparently there are a number of beneficial enzymes that are present in the process of worm composting. We're taking worm compost, and some other researchers that I'm working with are adding it to anaerobic digesters and getting an increase in 20% in methane production because of things that are present in the worm compost that can be beneficial. So I think we've just opened the door here, and that there's a lot more work to be done on how to really use our transplant production process to beneficially provide microorganisms and support the soil food web in our fields. The transplants, if they're healthy, it's going to be helping with your tunnels or with your fields, both with providing nutrients, microorganisms, and organic matter. One of the ideas that's been mentioned by Elliot Coleman is that if you use soil blocks that are, let's say, 50% compost, or media, potting media that's 50% compost, and you start planting those out in your field, let's say if you're doing lettuce on a 10 by 10 spacing, that the rate of compost that you begin applying to your field begins to get into the 5 ton to the acre or so. So it's another way of getting compost out into your field and helping to get those benefits out in the field.
Okay, one grower asks about what kind of price can you expect by, maybe if you're selling transplants, you're going to sell organic transplants versus conventional. What kind of price markup or difference might you expect?
Right, so if we think about markets, if we think about just selling transplants to people, let's say homeowners or someone who's going to plant them in their yard, I think it's going to be limited in terms of what kind of a markup or how much people are going to be willing to pay more for organic transplants. That was something that, when I was originally working with the greenhouse industry, that it seemed like it would be a harder sell to more people are valuing that. When it comes to selling to organic farmers that need to use, particularly certified organic farmers that need to use certified organic transplants for their systems, there I think there's an opportunity and a demand where the supply is short, and so therefore I think that would tend to support a good price for the transplants. We have some of a recent graduate of our organic farmer training program has taken on that as one part of her business, is to grow certified transplants that would be suitable for organic certification for organic farmers. And there does appear to be a demand and also an appreciation of somebody who is growing vegetables, particularly in hoop houses or high tunnels, where the transplant is just so important and your income from those transplants can be so significant that it's worth paying good money for good transplants. And that I think we're going to see an increased demand for those transplants, but I don't have any hard evidence yet other than what I'm experiencing here in Michigan and from the limited number of people that are growing transplants for sale. We have one large operation here in Michigan that came online in the last 3 years. That is 4 acres of greenhouse that could, and can produce certified organic production. Mostly they're selling to one of the large retail chains in the spring, but they have the capacity to sell to organic farmers if the demand is there. And I started out asking, do you make your own media or don't you? And we saw that 50% are buying their own, buying in media is, I think, what was correct. And growing transplants, buying transplants, making media, buying media, a lot of it depends on where you are in the farming process and how much time you have to do these things. And if you're new, you're probably better off focusing more on the growing in the field initially and buying some of those materials that other people can do until you get more experience, and then potentially later on it can help you in terms of cost savings once you have the experience of how to do it well.
Thank you, John. We're running out of time, but I'd like to thank you all for your questions. And as I mentioned before, if you have additional questions or questions that haven't been answered, you can use the Ask an Expert system at extension.org/ask. This webinar will be posted on the eOrganic website by tomorrow at www.extension.org/organic-production, or actually even more specifically at the link on the top of your screen. Thank you so much for coming today, John, and giving this presentation, and thank you, Vicki, for fielding the questions, and thank you all for joining us.